Welcome back to RamZland. Today I want to show you the reaction between elemental lithium and acetic acid. Check this out.
For this experiment, we're using a 1,000 milliliter graduated cylinder, a 250 milliliter graduated cylinder with 200 milliliters of distilled water, phenolphthalein as an indicator, elemental lithium that's stored in mineral oil because it reacts with moisture in the air, and acetic acid, which is also known as vinegar. The first step is to add 500 milliliters of acetic acid to your graduated cylinder. Next, add a few drops of phenolphthalein to your graduated cylinder with 200 milliliters of distilled water. You'll notice that phenolphthalein is clear in the presence of water or an acid.
Now you're ready to cut a small piece of lithium. Remember, lithium only has 3 protons, making it the lightest metal on Earth. It's an alkali metal that was discovered in 1817 by Johan Arvidsson in Stockholm, Sweden.
Here's what lithium looks like underneath that oxide layer. Very shiny, bright luster.
Okay, so before we add the lithium to the acetic acid to the vinegar, you might assume that it's going to catch fire. Because if you've been watching my channel for any amount of time, then you know that I've tested lithium with sulfuric acid, I've tested it with nitric acid, and it does catch fire and it produces a lot of hydrogen, but not necessarily with acetic acid. Remember, vinegar is a very weak acid. Check out what happens. Starting to fizz. It's getting hotter. So now the reaction is done, and the products are lithium acetate and hydrogen gas. And you saw the hydrogen gas form during the reaction. Now, what I'm curious to know is whether or not there was enough lithium to actually make that acetic acid not just pH neutral, but if it actually made it slightly alkaline. And if it did, it should change color when we add our phenolphthalein. Let's find out. Nope. It appears to still be slightly acidic.
Here's the balanced equation for this reaction. We start with the reactants lithium and acetic acid. We have 2 moles of lithium, that's the 2Li, and we have 2 moles of acetic acid, that's the 2CH3COOH. When those come together, they create the products lithium acetate and hydrogen. We have 2 moles of lithium acetate, that's the 2CH3COOLi, and the diatomic molecule of hydrogen gas, that's H2 in this reaction.
I hope you enjoyed today's edition of RamZland, and I'll see you next time. If you enjoyed this presentation, be sure to remember to like and subscribe.